next outcome pertains to graphing linear relations. You will demonstrate your understanding of linear relations through graphing a linear relation. In order to be a level 2, you are able to graph a linear relation given a table of values or ordered pairs. To be a level 3, you are able to graph a linear relation given the equation. And a level 4 would be you can perform error analysis, you can explain your graphing strategy, you can graph a linear relation given the context of a relation. So in this first example, we want to use a table of values to sketch a graph of the equation y equals negative 2x plus 5. Now this is something you would have done back in grade 9 and probably even grade 8. We are going to create an xy table of values. Now technically, to graph a line, you only need 2 points. But if all you choose to do is choose 2 points in your table of values, if you happen to make a mistake on one of them, you won't notice it because you can draw a point through any 2 lines. However, if you choose 3 points, it's a little bit easier to catch that mistake. 5 is recommended, but I'm going to insist that you show at least 3. Now what you're going to do is you're going to choose any set of values for x. Because there are no fractions in this equation and it's in the form y equals, it really doesn't matter which points you choose for x. You may want to spread it out a bit and you may want to choose negative 5, 0, and 5. You may want to stick right to negative 1, 0, and 1. It is recommended that you choose 1 negative, 1 positive, and probably 0 so that you have a nice variety on your graph and that you don't run out of room when graphing it. So in this case, I'm going to choose negative 1, 0, and 1. Now what you do to find the matching y values is you substitute that x value into the equation. So what we're going to do is we're going to substitute negative 1 into x, and now we're going to solve. Negative 2 times negative 1 is positive 2. 2 plus 5 is 7. So our matching y value is 7. And on our grid, we can plot the point that's at negative 1 and positive 7. And there's our first point. We are going to repeat this process by substituting 0 into the x spot. What we end up with is negative 2 times 0 is 0, and 0 plus 5 is 5. So our coordinates are when x is 0, y is 5. We put our next point. And we repeat this process one more time where x is 1. And it was a negative 2, so negative 2 times 1 is negative 2, plus 5 is 3. So when x is 1, y is 3. And we can determine that we likely have not made an error because these 3 points do line up in a line. And so we can join them, extend them, and put arrows on both ends. And you have drawn the equation of the line. We'll try one more example. In this one here, it is not in the form y equals. It does make it a little bit more difficult, but all we're going to do is we're going to add a step to it. We're going to rearrange it into the form y equals. So we're going to subtract the 3x. We're going to add the 12. So we have 4y equals negative 3x plus 12. And then divide by 4 every term. So y equals negative 3/4 x plus 3. Now because we do have a fraction, we might want to be a little bit more careful with the points that we choose for x. If we choose certain values, you're going to end up having to find common denominators and you're going to have fractional answers. If you choose x's smartly, you will eliminate that fraction. What you want to do is you want to look at what your denominator is. And in this case, it's 4. You want to choose values that can be divided by 4. So I'm simply going to choose negative 4, 0, and positive 4. Because what we will do now is we will eliminate the fraction. So we substitute negative 4 into the x spot. And notice how you go to multiply these, the 4's will cancel out. So we will, and this will just be a 1. So we will have negative 3 times negative 1 is positive 3, and 3 plus 3 is 6. So we will go 4 on the x's and up 6, and we will put a point. We will repeat this process with 0. So negative 3/4 times 0, and anything times 0 is just 0. So 0 plus 3 is 3. So when x is 0, y is 3. And now we repeat the process with positive 4. The 4's will cancel out, so we will have negative 3 plus 3, which is 0. So when x is 4, y is 0. And again, we will notice that we likely not made an error because we can join a line through these points, extend it in both directions, and put arrows on the end. And that is how you graph an equation of lines using a table of values.